and I'm presenting the EEG data for mental attention state detection. And this is important because as an application use, we could use them for determining attention states for pilots, whether or not they're focused enough to pilot an aircraft. So we have a Kaggle dataset with 34 experiments, and they had 5 human participants, and they were split into 3 classifications of state awareness: focused, unfocused, and drowsy. And these are split in 10-minute intervals where the total experiment lasted 30 minutes. And they were recorded through a 14-channel headset, and the Kaggle authors used 7 channels to determine the attention state. And their related work was using SVMs for a time series to classify their attention states.
Hello, I'm Michael. I'm the second presenter. I'm going to talk about our approach, which was not to use SVMs, but to instead create a convolutional neural network to classify images. What we used for input data to our convolutional neural network was spectrogram images. So we took the time series data of EEG readings and created a bunch of spectrogram images, which are essentially a frequency by time domain graph, where the color represents the power of each frequency. So in doing so, we took the 34 experiments, we took the 7 channels and the 3 classifications to produce 430,000 images that we labeled ourselves in order to feed to and train our convolutional neural network. So based off the things that we learned in class, we utilized 2D convolution along with max pooling, and to eventually, flatten and create a fully connected network in order to create our model. So we utilize gradient descent to optimize our model. We use categorical cross entropy, and we also use a softmax for prediction because we have more than 2 classes.
Hello, I'm Juan. I'll be sharing with you some of the results of the implementation. We divided the testing and training data considering this channel. That means that we have 1 model per channel and different training and test results. So for the models, we changed the parameters, we changed the number of layers, and we implemented also a dropout of 50%. The range of the testing accuracy goes from 52 to 63%, and as a way to see that is because of the computational limitations that we have, but using this model we can see that this is prominent, and a way to improve it should be considering integrating those 7 models and also using 3D convolutional networks.